Hey folks, welcome back. It's a rainy day outside, so it's kind of a perfect day for some math class. Today, we're going to talk about the difference between theoretical and experimental probability. Okay, so a simple way of thinking about this, take a quarter. Okay, you have a fancy little quarter, and when I flip the coin, how many possible outcomes should there be? There's two, right? Heads or tails. Now, if I would flip that coin 10 times, the odds of me getting heads would be how many times? Well, I should get 5 times, right? Because it's 1/2 of the possible outcomes. However, that's not always what happens, isn't it? You can flip this coin. If you have a coin, pause this video and flip it, 6 times. If you get, and I would guess that very few of you would get 3 equal ones, 1/2, right? Because in practice, when you experiment on a probability, it doesn't always work that way. Okay? Same thing with rolling a dice cube. I should roll a 1 every 6 times because there's 6 possible outcomes. But sometimes I can roll a 1, 1 out of 12. Or sometimes I get really lucky and I throw a 1 6 times in a row, right? The odds can change in real-world situations. So starting on page 721 in your online textbook, that's what we're going to be looking at today, theoretical and experimental probability. Okay, so let's look at the examples of wheel A and wheel B on page 721. When you look at probability, you look at wheel A and you see that it's divided up into 4 even sections, right? 4 even sections where you have you win, you lose, you win, right? Then look over at wheel B. You can see that 2 of the you lose sections are much bigger, right? Compared to the sections that are cut up for the you win. Now, here's what we're looking at right here. In a uniform probability model, each outcome has an equal probability of happening. So, for instance, in a wheel, if it has 4 sections, each section should have a 1 out of 4 chance, right? So which wheel has uniform probability? Which wheel between wheel A and wheel B would have a uniform ability to get the answer, to get the correct 1 out of 4 possibilities? Well, if you said wheel A, you would be right because both of the sections are divided into equal parts. But then you look at wheel B, you would see that that is not uniform probability because it's a little bit different, isn't it? So skip on down to number 3. Why would you think the winners on wheel A receive a less expensive prize than the winners on wheel B? So for instance, if we did this game where I had 2 spinners, we used wheel A and wheel B, and I spinned both of them. And I said, okay, if you spin wheel A, I'll give you a 50-cent prize if you win. But if you spin and win on wheel B, I'll give you a $3 prize. Why would that happen? Well, for those of us who are kind of looking at this and maybe thinking about times where this has happened to them, you can see that wheel B has a smaller percentage chance of winning, don't you? Because the sections are smaller. It's not uniform probability. Okay? So when the chances are less, the payout is better. This is why sometimes, like for those of you who like sports, this is why you'll sometimes see when you watch like a baseball game or you're looking on, maybe you go on ESPN app and you look on like the scorebook for the baseball game or the basketball game, you might see, the odds of the winner. That's for people who bet on them. The higher the odds that they're going to win, the less money they would win. But the smaller the odds, like 1 out of 100, you'd get more money. Okay? That's why the lower the probability, the higher the payout. Okay? So if we look over on page 722, we look at 2 terms, theoretical and experimental probability. Theoretical, take the root word. it's a theory, right? I flip a coin. How many times should I have a coin? How many times should it come up heads? It should be 1 out of 2 times. That's theoretical probability. How many odds do I? How many possible outcomes do I have? Right? 2. How many outcomes am I looking for? 1. 1 out of 2. But then I look at experimental probability. Take the root word. It's an experiment, right? An experimental probability is based on relative frequency, which is what actually happens. So when I flip the coin, if I flip it 20 times and I get 13 heads, that means the experimental probability is 13 out of 20. So theoretical is what it should be. Experimental is what it actually is. Okay? So let's look at that in real life scenario. An example. The graph shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Okay? Find the experimental probability of spinning red for this experiment. Okay, so let's get our pens and pencils or something like that to write some stuff down. So we see that we're looking for the P of red. Okay? We're looking for the P of red. So we need to put it the number of times red occurs over the total number of spins. Let's do the easy one first, right? How many times would the spinner be spun? It is 60 times. So that goes in our denominator. Then we go over to the red section. How many times was red spun? Well, that's 24 times, isn't it? So the probability of red, the experimental probability was 24 out of 60. Excuse me, 24 out of 60. Well, now I'm going to reduce that because I can take some numbers out of both. I can take a 6 out of both. I can take a 2 out of both. And when I take 6 and 2 out of both of them, I'm left with an experimental probability of 2/5. Okay? Now remember, that's the experimental. But here's the question. Let's look at number 2 then. Compare the experimental probability you found to its theoretical probability. If you have a spinner with 3 equal sides and you spin it 60 times, how many times should you spin on red? Well, if you think about it, if there's 60, there's going to be equal times, right? Well, divide 60 by 3. What's 60 divided by 3? It's 20, which means the theoretical probability is 1/3. Okay? Theoretical probability is 1/3. So when we talk about the experimental versus theoretical, experimental is what it actually is, theoretical is what it's supposed to be. Okay? So take a moment if you need to pause this video and look down on page 722 A and B, okay? Restart this video when you are ready to go and look at your answers, okay? I'm going to go through A and B one at a time, okay? So go ahead and pause the video. Hopefully you're back and you've looked at your answers. And letter A says refer to example 1. If the spinner was spun 3 more times, landed on green each time, find the experimental probability. Okay, so we had in the original probability was 21 times, right, for green, 21 times for green. When we're going to add 3, and it's going to be 24. Now, what would that new fraction be? Some of you, if you weren't paying attention completely, you might have said to yourself, 24 out of 60. But that's not correct. Because what else do we have to add? We have to add those extra 3 to our 60. So actually, our new experimental probability for the green is 24 over 63. Then we're going to reduce it. We always reduce it. Okay? Always reduce it. And so when I reduce them, I take 3 out of both, and I'm left with 8 over 21. Okay? Now, what should be, for B, what should be the theoretical probability? Well, the theoretical probability really didn't change because we added 3 to both. It still should be 1/3. 8 out of 21 is around 1/3. Okay? So let's look over then on page 723, okay? And let's look then at number 3. These are involving dice cubes. 2 number cubes are rolled together 20 times. The sum of 9 is rolled 8 times. What is the experimental probability of rolling a sum of 9? Okay, well, if I roll it 9 times, the number of times, well, I want to roll a 9 8 times. So I put my 8, and how many times did I roll? I rolled a 20, right? So I reduce that, and I'm left with 2/5. Okay? The experimental probability is kind of easy to find, isn't it? You just put the number of times you actually rolled it over the times it's just actual over possible, right? Not too hard. Number 4 says, compare the experimental probability you found in example 3 to its theoretical probability. If the probabilities are not close, explain a possible reason for the discrepancy. Now comes the part where we have to think about how do we sometimes find theoretical possibility. Think of a dice. How many possible outcomes are there on one dice? Well, there should be 6, right? How many outcomes are there on the second dice? Same thing, right? 6. How many outcomes are there overall? There is actually 36 possible outcomes. Okay? How many times would you roll? The probability of rolling that 9 would be 4 out of 36, otherwise known as 1/9. Okay? 1/9. So, what I want you guys to do, looking at theoretical and experimental probability, comment below and label your answers as either C, D, or E. I want you to pick 2 of those 3, okay? Pick 2 of those 3, C, D, or E, and give me your answers in Google Classroom below. All right? Hope you guys enjoyed this video. Have a great day. Hopefully it warms up and dries out a little bit for you guys to enjoy outside. See you later.